Hi everybody. Today we're going to take a few seconds to talk about the results on Friday's quiz. It was not our best quiz of the year, so I thought that it would be worth the time to give you a video solution of those answers. On the first problem, you were given this diagram and asked to find the value of x to the nearest tenth. If you took the time to label the diagram, we always know that the side opposite the right angle is called the hypotenuse. In a right triangle, that's always true. And the leg of the right triangle that's opposite the angle we're working with is called the opposite. We have our three trig functions that we should have memorized now. They're called sine, cosine, and tangent. And we have this saying, SOHCAHTOA, to help us remember which trig function we're supposed to use to help us solve a problem. So in this problem, since we have the hypotenuse and the opposite, we choose to use the SO part of the mnemonic because we have the O for opposite and the H for hypotenuse. So we use the sine formula, which is sine equals opposite over hypotenuse. When I substitute in, I get sine of 28, that's my angle measure, equals x, the opposite, over 17, the hypotenuse. To solve for x, I multiply by 17 on both sides. I need to make sure that my calculator is in degree mode. I round to the nearest tenth, and I get 8.0 for x. On the second problem on the quiz, we were given this diagram with the legs on the right triangle measuring 6.5 and 14, and the angle measured x, and we were asked to find x to the nearest tenth. So we didn't know the hypotenuse because there's no number over here, so we only have the legs. The leg that is next to the angle we're using is always called the adjacent. The leg that's opposite the angle we're using is always called the opposite. So we know we're using adjacent and opposite. So we look at our mnemonic again, SOHCAHTOA. The only one that has an O for opposite and an A for adjacent is that TOA. So we write down our tangent formula. Tangent of the angle equals opposite over adjacent. In this case, tangent of x equals the opposite 14 over the adjacent 6.5. And to solve for x, we take the inverse tangent of both sides. When we put that in our calculator, we get 65.1. The third and fourth problems were both word problems. In number 3, we were told that we had a ladder leaning against a vertical wall so that the ladder makes a 40-degree angle with the ground, and the top of the ladder touches the wall 20 feet above the ground. To the nearest tenth, how far or how long is the ladder? So to answer this problem, you really have to draw a diagram, and typically our ground is horizontal, our wall will be vertical, and then our ladder will make up that diagonal. And then we fill in the information they give us. We're told that there's a 40-degree angle with the ground, so the ladder and the ground make the 40-degree angle. We're told that the ladder touches the wall 20 feet above the ground. Well, to measure the height above the ground, that's always going to be a vertical, so that's our 20 feet. And we're asked to find how long the ladder is, so I'm finding the diagonal, which I'm calling x. Since I'm using the side opposite the right angle, I'm going to call that the hypotenuse. And I'm using the side opposite this 40-degree angle, that's my opposite. SOHCAHTOA tells me that I should use the sine function because we have opposite and hypotenuse. So my formula is sine of the angle equals opposite over hypotenuse. In this case, sine of 40 equals 20 over x, where 20 is opposite and x is hypotenuse. To solve this, I chose to put sine 40 over 1 and cross multiply. X times the sine of 40 is x sine 40. 1 times 20 is 20. I divide by the sine 40 on both sides, and I get x equals 31.1 feet. The last problem on the quiz said that a 45-foot guide wire is attached to the ground and attached to the top of a 35-foot telephone pole. To the nearest tenth, what angle does the wire make with the pole? I underlined wire and pole there because it's important to know where to put our x for the angle. Again, ground's horizontal, our pole's vertical, and our wire is going to go diagonally. If you don't draw a reasonable diagram, you're going to have a very difficult time solving these problems correctly. We have the 35-foot pole, so that's my vertical. And I'm told that the guide wire is 45 feet long, so my diagonal is 45 feet long. And I'm finding, like I said, that angle between the wire and the pole. So there's my X. When I label my sides, I'm doing everything based on the right angle. Remember, opposite the right angle is always the hypotenuse. And then my leg that's next to the angle that I'm using is called the adjacent. Since I have adjacent and hypotenuse, SOHCAHTOA tells me that I should use cosine because cosine has adjacent and hypotenuse. So cosine of the angle equals adjacent over hypotenuse. In this case, cosine of x equals 35 over 45, 35 being adjacent, 45 being hypotenuse. To solve, I take the inverse cosine of both sides, round to the nearest tenth, and I get x is 38.9 degrees. For today's assignment, I'm going to have you do some more practice with your trig because I don't think that we've all mastered it yet. Good luck with those problems. Please feel free to contact me if you are struggling. Thank you.